Now, Dynamesh is, quite an intensive process. So this model already was 2 million polygons, and then I threw that other piece on it, so it's about 4. But you can see, there you go. It didn't take too long, and now it's punched that key right out. And now if I turn that solo off there, you can see now I have that keyed shape. And if I move it up, you can see it's going to fit nicely right in that hole. And there's a little bit of, you'll notice that even when I undid the position here, I have a slight gap right through here. And that's because when I did my inflate, I didn't move that piece off a little bit. Right, so I didn't account for the inflate thickness going this way when I did my subtract. But there you go. That's the simple solution for keys inside of ZBrush. Now both these pieces are, you're done now pretty much for printing. So they're both watertight since they were all Dynameshed, and they all have their keys set up so you can print this part, and they'll go together nicely. So now that we have them keyed, we're going to actually go through and talk about shelling. So oftentimes you print on a MakerBot, it's nice because it will only do the outside and it gives you support structures through it. If you send stuff to Shapeways, if you printed the solid, it's going to cost you a lot more through Shapeways, right? But if you hollow it out, you get the same object, and it's not going to cost as much. Same with things that sent to the Form 1, things like that. A lot of resin to do a solid model. So hollowing it out is definitely beneficial. So I'm going to load this other model here. So here we have some little chess pieces. These are all based on cephalopods. And then these are actually sitting up on that booth there, kind of printed out on the MakerBot. And these were all done inside of ZBrush. The tentacles were done with basically the same functionality with those insert mesh brushes. So I made one tentacle and then started moving it around. And it gives you this really kind of quick result to take parts and kind of kit bash them on your model. Now I'm going to show you guys how to hollow this out quick. Just go to this guy. So the hollowing process inside of ZBrush is simple as well. Just frame this guy here. So we have a little cuttlefish, cute little cuttlefish here. He is already Dynameshed, so you can see I have him all kind of nice and topologize all. He's watertight all the way through. And I should actually have Dynamesh turned on. Now I'm going to do this at a little lower resolution because the shell process sometimes can take a few minutes. So for demo purposes, I'm just going to do it at this resolution. So I'm losing some of the details here. But in general, when you do this for real, you wouldn't have any problem with the shell. It just takes a little while because it's really computer intensive. So to make a hole in here to shell it, to shell this out, I just have to make a hole. So I have to take an object and make it so it's a subtraction object, and then put that on my model somewhere so it penetrates it. And after that happens, I hit this create shell button over here, and it's going to go and create a shell based on the thickness of the slider right here. So I'm going to go back to that insert cube brush that I've used quite a few times, and I'm just going to draw this out here, hold Alt, and draw that on the model. So like that. And now I can just move this into position. So something like that. And now I'm coming over to create shell and just click it. I got to clear my mask first. Boom. Your object has just been shelled. And if I get it back on here so you guys can see this. Oh, if we come back to me. There we go. There we go, cuttlefish. So we've just shelled that entire model. Now, if this wall thickness looks too thin, you can just undo this, change this thickness over here, and then do create shell again, and it'll give you another shell. Now, what this process does is it went through the entire model and created a shell based on the outer structure, and it's calculated inward. So if I turn on double-sided here, so you can see the back side, so you can see I have a nice thickness that's going all the way around the model. And it's still retained that watertight structure across the entire mesh, but it's just shelled the entire thing in no time. Now, if you notice in here, I have a lot of kind of topology going on here, and some of these may give you overhangs, which are going to require support structure, right? And so we don't want that. We want to kind of, if we're hollowing something out, we don't want all that inner support. We want as least amount of support as possible because that's why we hollowed it. So to do this, we can quickly clean this up as well. So first I'm just going to isolate part of the mesh, just so I can get the bottom or the base cut off. And now I basically, if you look at this model, it has two islands. So I have made a clear disconnect between the two surfaces. So I have an inner surface and an outer surface. So it's a two-island object now, basically. And now if I come over here to the polygroups and do an auto group, it's going to give me a new polygroup for each of those islands. So now I have two individual objects on this model. So now I can hold Control and Shift and get all my model back. And now I can hold Control and Shift again and just select that inner portion. And it's only going to show me that inner portion. Because what I want to do on this model is I want to be able to polish or clean up this intersection, but not distort the outer part of my model. So to do that, I just simply cut off the base, which allowed me to break that connection of that model being solid, did an auto groups, which gave me two polygroups, and then brought it back. So now I can isolate that intersection. So I just cut it for temporarily to get the parts broken up into two, and then I can get two groups on it to isolate that intersection easily. Now once I have this, I may want to extend this to that hole. So I want to get the entire interior surface, not just up to this point, because I did a slice right through here. So I can grow the visibility on this right now with the model. So if you come over here to visibility, there's a grow, and it's going to grow it on a polygonal level as many times as you press that button. So you can see it's starting to grow to that hole. So I'm just going to grow this quick until it gets to the edge of that surface right there. And then I'm going to hit Control W or come over here to polygroups and do a group visible. And it's going to give me a polygroup now for that whole structure. Now I can hold Control Shift and just click off, which will invert my visibility. And then I can give this outer one all new polygroup. And now if I hit Control Shift again, I now have this model into two polygroups. So I got the full inner structure and that full outer structure. And this is now allows me, a little more freedom on my model to go in and clean up this inside. Like I'm not going to worry about polishing this side out and distorting that other part. Now once you start polishing stuff like this is also beneficial in decimating. So right now this model is pretty low, but if I go back to an actual version of these guys that I've actually cut up, I think I have one of these guys here. So here we have this model. And this was done in ZBrush as well. And it was just literally, it was a test piece for the actual contest that happened yesterday. So he wanted to throw a whole bunch of complex stuff at it to make sure it worked. So I just went through and started sticking stuff on this. So I kind of, went through thinking, okay, we're going to make a lot of this watertight. But I didn't expect a lot of this to print. So I wanted it to kind of fail, and it didn't fail at all. So this print, we have it done. We have it holed out, right? But now it may have been too heavy to send to the printer. So you can see I did that same thing where I have the inner surface. I went through and smoothed all that part out, and now I have the outer surface. So if you send it to a printer, right now this is 1 million, so you probably could send it and be fine. But say it was 5 million, 6 million. It's too dense to send to a printer. But right now, I have this model. It's colorized. It has colorized information. And I wanted to get it to print out like this. So I wanted to get it print out in color, but I can't send my 5 million polygon model. It's too heavy. It's going to crash the machine that's at the printer, and I'm not going to be able to use it, right? Well, ZBrush has a process called decimation. I'm going to come here and just run this quick. And it also, well, let's just talk about decimation first. So ZBrush has a process called Decimation Master, which is a plugin. And what this does is that it processes your mesh, it looks for all the edges on your model, and then allows you to dynamically untessellate the model, but keep the edges that matter. So it's redoing all the tessellation on your model, but holding the edges you want to hold. So it's keeping all your detail, but reducing the actual polygon count of your model. So right now this model is 1 million. And so I just run the Decimation Master, which allows me to pre-process the model. And now I can come down here to this slider, and I can type in a value. So say, this for games, for printing, say 50K is what I want this model to be. So I'm just going to type in 50 and hit OK. Enter, and then hit decimate current, and it's going to decimate that model down to 50K. Now, 50K for this model, since I have this nice interior surface, is not going to hold the detail the way I want it to. So you can see here, 50K was a little bit too low for this guy. But if I go back up now and change to, say, something around 250, decimate current, we're getting a little bit better, you can see here. Now, this model was already decimated, so it's probably a little bit bad test case here. But you can generally decimate all your models as you're working on them. So if it's 5 million and then you decimate it, so now I've got it down. Yeah, so here's a good example. So it went from 1 million to now under 400,000. and your detail loss there, can you guys see it? There you go. So this is decimated, undecimated. You guys see anything? You lost about 500,000 polygons. You can't tell. So here's the polyframe of the two difference. So this is the decimated version. Get out of that thing there. And the undecimated. So quick way to take your high resolution meshes, bring them down, and not lose any detail on your model, and send them off to be printed. Now, as you notice, this guy, when he was undecimated here the first time, back up here, he had all this nice coloring too. So I want to send the coloring, right? I don't have any UVs on this guy. If I was going to make a UV map on this, it would take quite a while. But VMRL will allow me to send colorized information, right? I can send the colorized information right from the file to the printer, and they can then print it out in color. So I don't need UVs. I just need a model that has polypaint or vertex coloring information on it. This model we talked about, 1 million is too heavy to get printed. So I need to decimate it, but I also need to hold that color information. So over here in the Decimation Master, there's an option to keep and use polypaint, right? So if you turn this on and now pre-process, it's going to hold all those color values and try to hold a line around, a polygonal line around all those elements so it can fill it with color and hold detail. So now if I dynamesh this, or decimate this, you're going to notice it's going to keep that structure and keep the colorized information and take my polygon count down. So we just processed it, and now we're going to go back to that 800 and decimate current. And this function also allows you to decimate a whole bunch of meshes. So if you have a whole bunch of tools in your file, you can do it in a batch process, which makes it a lot faster than doing it one by one. And this is also great for just if you have a part and you've got it exactly where you want it, and you're not going to have to do any more sculpting on it, it's done. But then you notice that you have 4 of these parts, so your whole scene is like 15 million, 16 million, so it's kind of hard to work with. Start decimating those parts down. Since you're done with them, you can decimate down to 30K, 40K, and then you can work on your rest of your model, and they're going to be lightweight now compared to the original millions of polygons they were. So it's a nice workflow to kind of reduce parts of your mesh. You're not going to lose any detail, especially if you haven't done being sculpted. So now, 800K, got the coloring on it, decimating. And so there's the decimated version with the colorized information still stored on the model. So if I look at the polyframes, you can see it's actually generated lines of topology around all those little bits and decals and everything else I have in my model, so it can hold that information through vertex coloring. So quick way to get that stuff done. Now, let's see what I got on here. Now that we got our model set up for, we got it decimated so we can go to a printer. We've got it hollowed. We made it watertight. We made it hollow. We got the colorized information stored through a decimation, so we can send it to a printer. We're just ready to kind of get it printed out. But say we want to check some of the sizes in ZBrush. Like say we want to check, okay, so say this model is going to be 6 inches tall. Well, how thick is this actually going to be? How thick is that area actually going to be on the model before I go through the work of, sending it to the printer and they come back and they're like, your wall thickness is too small. So here I have a little thing that I made for the conference here. This is a ZBrush wall tester, wall thickness tester. Now, I sent this to the MakerBot 2 and hoped it would fail. It printed all the walls. It didn't fail on any of them, but I'm pretty sure I didn't measure it with a caliber yet because I didn't have time. But I'm not sure if this is 0.01. It looks a little bit bigger than 0.01 for the wall thickness. But it didn't fail. So you definitely can print the smaller size lines, but not quite sure if it's the exact dimension. So here I have a wall thickness tester. Now, this right now is kind of, the scale value of it's kind of arbitrary. It could be whatever size I want it to be. But I know that the dimensions of it are what I kind of set it. So I know that 1 centimeter here, if I took this 1 centimeter, this size that's right here, and duplicate it across, it would be 10. right? So even not even thinking about centimeters or just thinking about generic units, this is 1, and all the way across would be 10, right? But so you can pretty much determine that, you can say it'd be 10 centimeters, you can say it'd be 10 inches, whatever you want it to be. It's just a generic kind of global value between those two. Well, now, ZBrush has a function in here using this transpose line that you can use it as a digital caliber. So right now, if you kind of stretch this out, you can see that it's giving me these unit values up here. So it's giving me this arbitrary 4.53 units. Well, I know for certain that if I go from here to here, along this line, that should be 10 units, right? Or 10 whatever I want it to be. So if I come over here to Preferences, I can go to Transpose Units, and in here I can set the calibration distance. So say I want to work in millimeters on this file here. This is my constant. I know my constant needs to be this size. So if you have a bolt on your model, and you know that bolt, if you need to actually screw a bolt in the real world, and you know the dimension of that actual bolt, you just need to set that size. So if I know for sure that I need this to be 100 millimeters from here to here, just plot that out with the transpose line. Then I'm going to go to Preferences, and I'm going to change my units here to millimeters. And I know that this calibration distance right now that's showing, I want it to be 100, so I'm going to change this value to 100. And now this transpose tool is now set up to give me the value that I want. So right now, if you come up here and look, it's telling me this is 100 millimeters from this point to this point. So now with this, I can now go around my model and draw a transpose line, and wherever it's positioned on the model, it's going to tell me the value in millimeters. So I can come and select here to here, and it's going to tell me it should be 1 millimeter. So I can now go through and you can check your model. If you know one constant value on your model, that's all you need is one constant. You plug that in, and now you can check all different sizes on your model around it. Now, it's a little bit time consuming to kind of go around the model. This transpose line will snap to points on your model. So if you click on if you go to a point, it'll actually snap to the vertice. So this mesh right now has been decimated and had some lines held. So it's really clean. So each point is actually falling right on the edge. So this makes it easier. 5 minutes? Wow. Makes it easy to kind of snap through the different parts. But that is a unknown little tool that's in ZBrush that a lot of people don't know about, is that you can set units with transpose and then use it to guide. This also works for like head heights. So if you make a head and you're like, okay, I know the distance from this transpose line, the start to the end of the transpose is 1 head, then you can start pulling out a form and get your transpose line and see if it's an 8 head tall person. So it's just a quick way to kind of go through that stuff. So now that was just a little thing there with the transpose. And I've got 5 minutes left, so I want to just kind of show you guys how to export this stuff out. So here I have a simple object. This was actually set up for the contest. This is just a box we made because we needed all the contestants to fit in a 6x3x3. And so that we could actually get them printed out on one bed in one go. So that was the confinement or the constraint. So this box was just generated quickly and imported in. And so I've just placed my model inside of it. So I just need to fit in the volume. So now I want to export this out. So well, how do I do that? Well, you can export an OBJ and you can bring it in, you can mess with scale and all that stuff, but that's a pain. ZBrush has a plugin called 3D Print Exporter. And in here it has a whole bunch of tools you can use to export STLs, VMRLs, or OBJs. So right now, I have this box, and I know it needs to be 6x3x3. So you're going to first come in here and just hit Update Size Ratio. And what this does, let me just dock this over here to the side, because we're going to go back to this quite a few times, is it's going to look at the bounding box of everything in your scene and tell you the values. So right now, this is coming in exactly at 363, because I know this box is 363. Well, say I want to double the size of this, right? I want to send it out. So if I, well, if I export this out right now, it's going to give me that exact proportions. It's going to be perfect, 633. Say I want it, I want not 3 inches this way, I want 6 inches. We can come here and change this to 6 now, and then hit enter, and it's going to update all your other values. So you can instantly size your scale of your object right through this tool. And then after you have the size or the dimension you want, you now have the option to do visible, selected, or whatever is over here on your subtool. So I just want this. I don't want the bounding box anymore, so I'm just going to hide that bounding box. I'm just going to make sure this have on selected, and now I can just export it out as what format I want. Now, if you need certain kind of formats for your STLs and stuff, there's a whole drop down here, so you have all different variations. So I know that If I want to just export an STL, I can just come here, selected, click STL. There's my STL file. I wanted this to be in color, so I needed to send it as a VRML, right? So I'm going to come down here and make sure I don't have any textures associated with it. It's just colorized information or polypaint. And I'm just going to make sure color is on, and then just have selected and VRML, and now there's my VRML file. So this process on how this got sent, that was it. I set my scale over here for that bounding box dimension, a 363, turned on color, or turned textures off, and then just hit visible, selected, and VMRL, went straight to the printer, and then came back like this. So no extra cleanup needed, all inside of ZBrush. So there's a lot of stuff in here. It's an extremely powerful tool, and just the creative and kind of free-flowing qualities of the program it's really easy to kind of manipulate your forms and shapes and change things on the fly. But if you think about it as digital clay and think about it as sculpting on a computer, it's going to come a lot easier. And just keeping that mentality to it. It's a very simple process, and they're just doing it. They're using it as they would in clay. Well, if you have any questions, I'll be around for the expo. I'll probably standing around here. And I hope that answered some questions and it wasn't too confusing for you guys. That's all I got.